All right, hope everybody's having a good day today. This is the second part of section 7.7, finding an inverse, okay? And we're going to talk a little bit more about the domain and range and how that works in this setting, and looking at a little more difficult setting, if you will, okay? So now, if this is my equation here, consider the function f of x. That's basically, again, the same thing as y equals 2x plus 2, right? So now, if I want to find the domain and range, well, we did this yesterday with the square root function. Hopefully this makes some sense now. For domain, I got to say, well, this stuff has to be greater than 0. So for the domain, 2x plus 2 is greater than or equal to 0. Subtract the 2, divide, and x is greater than or equal to negative 1. That's my domain. For the range, well, first of all, I know y has to be positive to start, because nothing can come out of here, out of the square root sign, and be negative. And really, there's no further information there. So basically, I have to say for the range, I have to say that y has to be greater than or equal to 0. Y must be positive, okay? Because whatever I plug in for x, y is going to come out positive. That's my reasoning there, if you will, okay? So now for the inverse, let's go ahead and find that algebraically. Let's go ahead and find that algebraically. I know you could do a picture, which let's go ahead and just plot this guy out real quick over here. If x is, where did I say my domain is? X is negative 1, y is 0, and then if x is 1, y is 2, and this is my basic picture, a little half parabola guy going right there. Okay? So right away, I should be able to say, well, the inverse, first of all, I know in a picture sense that it's going to just flip over the line, y equals x. Okay? So what does that look like algebraically? Let's go ahead and take uh, y equals square root of 2x plus 2. Flip our x and y. Isolate y. Okay? So I got to square both sides. Okay? Subtract 2 and divide, and I get y inverse equals x squared minus 2 over 2. Okay? Again, you might see the notation that way. You might see it written this way, so forth and so on. Okay? So now, what does that mean? That means basically this guy, without even having to graph that thing, I should first of all talk about the domain and range. Well, the domain and range of my inverse has to match with the domain and range of my original function. In other words, the range of the first one has to go with the domain of the second one. X has to be greater than or equal to 0. And in a picture sense, well, if this flips across here, that works. Okay, X has to be greater than or equal to 0. And also for the range, well, what was the domain of my first? X is less than, or greater than or equal to negative 1. So y has got to be greater than or equal to negative 1. Oh, check this out. If I start working this way, boop, that works. Okay? So now I get, this crossing point here and this guy. From my picture and from the work that I've done, I should be able to say that the inverse is a function. Okay? Fair enough? All right, so we've had a little bit more in-depth conversation about domain and range and a square root function. So now let's go ahead and move into how can we apply this, Mr. Roderick? Well, it's actually pretty easy if you think about it. Basically, this function here, distance equals 16 times the time squared. Distance, feet, time, and seconds. find the inverse function. Use the inverse to estimate the time excuse me, it takes an object to fall 50 feet. Okay? So basically, well, this kind of makes sense. I want to take this equation and set t by itself. So now, even though we were been flipping x's and y's, well, since time is a specific thing, it's not just some variable that we're plotting. I can basically say d over 16 equals t squared. Take the square root of both sides. And so that's t. And basically, I'm not interested in negative distance or negative time here. So time equals the square root of the distance over 4. Well, if I'm going to solve this equation, hopefully they give me the distance. 50 feet. There you go. So time equals the square root of 50 over 4. Square root of 50, we know as a decimal is 7 point a little bit. So 7 point, let's call it 7.1 over 4 seconds. Okay? So quick application of finding the inverse. And you do this all the time. You take variables and solve for different variables because that's what you want to talk about. Okay? So now the last thing is just kind of a notational effect here. And basically it's just, again, going back to composition. Okay? Composition, again, is plugging one function into the other. Okay? So if the original function f and its inverse are functions, are inverse functions, then we can say the inverse composed with the original is x. So you compose that all together, basically, and you get whatever is in this slot, basically. And then also, it's got to work in both directions. So the original composed with the inverse should also be x. If they are both functions, this is, if f and f inverse are inverse functions, then this is what we got. Okay? So now, well, so how do I use this? Okay? So for the function f of x equals 1 half x plus 5, I know that's linear. I know its inverse is also a function. So this should all work. Okay? So the inverse composed with the original, 652, must be still 652. Okay? Doesn't change. And this guy going the other direction, the original composed with the inverse, negative square root of 86. Okay, whatever. It's the same number. It doesn't matter what it looks like. It's going to equal the same number. So whatever you're plugging into the function is what the function turns out to be. Okay? That's the bottom line on that, and that's everything for inverses, and that should cover everything. What you can do with an inverse, you can graph it, you can get an algebraic representation, and then you can flip it through the line y equals x, and you can use it to solve a real world equation. Okay? Hope you're having a great day, and we will talk to you soon. Thanks.